All right, I'm going to kick us off here. I have the honor of at least talking to you a little bit about company, the organization that we come from. So I'll tell you a little bit about that. But while I was listening to the keynote this morning, it reminded me that I've been doing operations for about 20, 21 years in healthcare software, and that presentation reminded me how the decisions, the architectural decisions, really affect my career and affect the people that work in my department. We've come a long way from deploying on-prem client-server-based systems to what you're going to hear today about our deployments in a cloud-based architecture using containers and all the newer technologies. So anyway, hopefully you find this enlightening. So we're from Pittsburgh, Pennsylvania. This was working a second ago. So UPMC is what they call an integrated delivery system, and what that is UPMC has a provider side, which is hospitals. So UPMC has more than 25 hospitals, academic, community, and regional in the Pittsburgh area, Western Pennsylvania. They're actually expanding eastward as well toward Philadelphia. So UPMC just did an acquisition with Pinnacle Health in Harrisburg. So we're expanding into the middle of the state and actually going east. Maybe someday we'll take over the whole state and cross the state lines. But as part of that integrated delivery system, UPMC also has a payer side. We have a large health plan. UPMC health plan has over 3.1 million members. A network of 125 plus hospitals, over 11,000 physicians. So pretty big in terms of health plan, cover most of Western Pennsylvania. UPMC is also an academic health system, so affiliated with the University of Pittsburgh. So anybody familiar with Pitt? Might be people in the room from CMU. CMU is right down the road from Pitt, but academic health system, do a lot of research, a lot of grant work, things like that at UPMC. And also, UPMC is known, they have a Center of Excellence in transplants, do about 650 transplants annually. I think everybody probably heard recently one of the pioneers in transplants, Dr. Starzl, passed away this year, I believe. It's from the University of Pittsburgh. So, go on to the next one. So if you ever wondered what type of infrastructure it takes to run a health system of that size, UPMC has over 1,000 applications, 1,102 to be precise, various applications. One of the unique things about our health system is UPMC uses two EMRs. They use two of the largest, one Cerner, one Epic. So it's very challenging. We like to call UPMC out at UPMC Enterprises, which is our development shop, I'll tell you a little bit about, but we like to say we have champagne problems there. So a lot of activity, a lot of different systems, a lot of things, a lot of complexity in terms of how UPMC is run, and having two of these EMRs is one of those systems. A lot of data domains as well. Petabytes and petabytes of data at UPMC. So one of the things that we work on is trying to harness all of that data. So we have projects that we run in AWS where we take all of the data within UPMC and we try to harness it so that we can actually build applications on top of it. So you'll hear a little bit more about that later. All of that data has different data owners, so it makes data acquisition a little bit hard, challenging, and data governance challenging. A lot of that data obviously has PHI in it, so a lot of strict data governance policies and procedures to actually get access to that data and house it to be used by our applications that we build. UPMC Enterprises. So this is where Greg and I work. This is not part of the provider or payer side that I talked about. This is another division within UPMC, really the third leg of the stool, if you will. We're actually an innovation center, development center. We have over 130, 140 developers and architects, as well as some operational people. We actually take tons and tons of ideas great ideas in the healthcare space, and we innovate. We try to build those particular applications, build that software. So we're not just dealing with one piece of software, we're dealing with numerous pieces of software that we're building. Some we're building and failing fast on, some we're actually building and commercializing, turning into commercial ventures, which is one of the charges that we have at UPMC Enterprises, is to not only develop these new technologies, but also commercialize them or create new companies. So we call those portfolio companies. So we're charged with building a lot of portfolio companies for UPMC. Another thing that we do heavily is invest. So we have a large fund, venture capital fund, UPMC has, that we invest in technology companies. So we buy a lot of early stage technology companies that we bring into the fold. My group is called Client Services. One of the things that we're responsible for is helping those companies launch into the market. So these are a bunch of new startups, very unique. So I talked about my group a little bit. You're going to hear a lot of it in this presentation. Our group is called Client Services. It's really operations. But what we're responsible for is implementing and supporting the technologies that are built within UPMC Enterprises, or the technologies that we acquire, or new companies that we acquire. So we do pilots or implementations inside of UPMC. So some new software that we build, we install it in UPMC and start these pilots. And we also take things into production and support production systems as well. The way that we're organized quickly, our org structure, we have on the business side within UPMC Enterprises, we're organized by these domains that you see here. So we focus, very focused on translational science, improving outcomes, infrastructure and efficiencies, and consumer. So any idea that I talked about that we get in from the community or wherever ideas come in from, they have to fit into one of these domains and make sure that they fit in order for us to take that project on and start to build that. Here's some of our success stories. I talked about some of the businesses that we either launch out of UPMC Enterprises or acquire. Some names up here. MedCPU is based out of New York, and their clinical decision support system. Got Health Catalyst out of Utah, which deals in big data and enterprise data warehouse technologies. We got other technologies like Lantern, which are digital therapeutics companies, a new wave of technologies that have clinical-based systems on your handheld device, where you can actually get digital care through companies like Lantern. So these are a few. I think last year we had a big one went public. It was called Evolent Health. Evolent Health is a consulting organization that actually goes out with other integrated delivery system type hospitals and teaches them how to build what UPMC has been able to build through a payer and provider network. All right. So at this point, I'm going to turn it over to Greg. This project, Voltron, is what we called this endeavor at Enterprises. My boss, Adam Berger, who's the CTO there at UPMC Enterprises, came to us about 18 months ago and said, look, we have a lot of operational inefficiency buried into our development operation. Use the client services team, take that inefficiency out, or take that all that operational activity out of the development group and put it into the client services group or the operational groups, and really start a very robust DevOps model here. So what was happening at the time, quickly, a lot of the operational components of supporting the systems, deploying systems, things like that, that was happening within the engineering and architecture groups. We actually started about 18 months ago with Project Voltron to try to figure out how we can actually pull that out, put it into operations, and actually build our operational competencies around cloud-based technologies, container-based technologies, things like that. So, Greg.
Can you hear me? Yeah. Good morning, guys. Pleasure to be here. So as Paul said, it's all about our Voltron project that actually combines the migration to a cloud environment, as well as introduction of the DevOps initiatives and practices. How many folks actually work now in the cloud environment or introduced cloud environment? Quite a few. And how many of you actually work with DevOps teams or maybe in DevOps capacity? so we know what we're talking about. So we actually had those both goals in one project, and if you look at this slide, it tells you about the this baseline state. That's where we came from. The organization is very matured and was very matured on the process. When I joined the company 3 years ago, they already had Scrum and mandatory training. So even though I was a principal architect, I went through the Scrum training. And so do all the project managers and development managers, right? The architecture team was very good, had solid standards, or at that time we thought that was pretty complete standard published in some sort of Wikipedia. And also we had quite a few tools that you could see here. I hope I can make it work. Yep. That actually, they were used to share some knowledge, right? Do the code management. And also there was a flavor of collaboration here in Wiki's area, in SharePoint. We used Jira at that time for issue tracking, mostly issue tracking. And also, as Paul mentioned, the client services team was not involved in the development operations, right, in the code deployment. So they never participated in infrastructure planning. And that was probably one of the biggest challenges there. And also to note, we are different from the UPMC at large, right? But we had dependencies on the UPMC Information Services Division. And those of you who work in the cloud, they probably know you have to open a ticket and wait for somebody to build a VM for you, right? Or maybe deploy software on the bare metal server. So we had those dependencies at the beginning of the journey as well. And needless to say, it slows down the progress, right? So we wanted to be more agile. We wanted to be more, I would say, automated. And this initiative helped us. I should say, as an architect, at the beginning, I didn't know much about DevOps. And as people started talking about DevOps and the architects and developers, along with the client services team, started discussing, you know, the delineation of responsibilities, roles, duties. It became obvious that this area is pretty complex. And if you make the right choices, people may collaborate really well. If you make poor choices, that will impact your velocity of your projects. And in general, it may create some tension between DevOps and the development organization. So we try to avoid that as much as possible, right? I took class last year at SATURN 2016. So that was probably a big jump start. That's where we picked up lots of ideas, and it was a nice chance to kind of get a bigger perspective on DevOps. Our plan that we worked on almost a month included those 5 functional areas that you see here. And it's kind of challenging because transition to the cloud by itself was a big undertaking, right? And introducing DevOps into that mix was an even bigger challenge because you kind of work out new collaboration patterns, right? New techniques, continuous integration, deployment automation, all those things, they kind of thrown into the mix, and you have to sort those things out, right? And at the same time, you have to remain secured, you have to govern your data, and you want to be cost efficient, so the optimization comes to play. So when we put together that plan, that was a large, really large spreadsheet that included all these items broken down by functions. We mapped each function to service or technology or tool, and also we tried to project what kind of people resources we need, right? What kind of skills we need to fulfill those functions. And that was pretty interesting exercise because initially we thought maybe we need new architects with deep knowledge of the cloud, right? Maybe we need people that actually went through DevOps implementation and have deeper knowledge in DevOps, right? And we identified those as potential constraints because we didn't have those people in our team. And we also did some gap analysis in terms of security and the development practices, and maybe some tooling was missing as well. So we marked those items with color-coded cells. And, you know, if we had a chance to show you that spreadsheet, it had quite a few red spots and some green items and everything. So it took us a few iterations to actually just build that plan. And like I said, the whole thing took a month, right? So we thought we did pretty good planning up front. So we knew the journey, we knew the roadmap. If you look at the top priorities in each of those areas, we tried to identify the most critical items that we thought would be important for our success, right? So DevOps team would participate in the infrastructure planning in each team. And Paul talked about our portfolio companies, and we have new projects in works. So each team would actually have a DevOps person engaged in the meetings and helping them to do the infrastructure planning. And also, if you think of configuration management tools, we thought that DevOps client services teams with DevOps people would actually get engaged in offering the infrastructure in the cloud and build some sort of templates that would help the development teams to get jump start and you know, just go directly to development without thinking about you know, low-level details, infrastructure related items, services that may be needed for their projects. And also, client services team would be useful to do this, provisioning and decommissioning the processes, managing the infrastructure, and monitoring the not only the infrastructure and services, but also monitoring the implementation of these security rules, and get engaged in the key management and be the owner and the gatekeeper to the stage and production environments, right? So I think one of the items which is a big dependency here is the connectivity to your data centers, right? Because once you are in the cloud and somebody's coming from the hospital side or from health plan side, they still have to have access, secured access to the cloud environment. So this one is big. If we look at the infrastructure monitoring things, it's really good when your client services or DevOps people actually help you to estimate what kind of SLA you have to support, what would it take to support those SLAs, right? And also help you to manage your stage and production environments by doing continuous monitoring and accumulating some knowledge, what it takes to run your operations in the stage and production, right? And once they accumulate enough knowledge, they would actually consult the other teams on those issues. And going through several iterations, they would just simply get better and better. This is important. We just talked about this. Security management, because obviously things happen, and we thought that the client services team would be the gatekeeper, right? If there's a troubleshooting or something happens in production, they would actually grant you as a developer permissions to do certain things and then revoke those permissions. So they would be like a gatekeeper in there. DevOps teams, at least in our life, they just facilitate the code deployment and change management. They do not really drive those things. And also consult on the application security and compliance rules. And that's really important. That's a key item. We will talk a little bit later today. So if you look at the information management and governance. The role of the, that's what we thought, that the role of the client services team would be to monitor the data use, help the governance team to analyze data being accessed in production by facilitating the HIPAA log files moving across environments, right, or to the analytical tools. And what's more important, this is one of the items that we thought would be the most challenging one, and I think it is still a challenge. When you have real production environment and you have to maintain access controls and security rules, that could be a very, very tough challenge, because with all the activities going on and troubleshooting potentially, you have constantly reconcile differences between your security blueprint, what you wanted to have, and the real implementation of your environment, of those rules in your environment. It sounds almost funny, but initially we thought we would not get engaged in the cloud optimization, because when we sat in the room, we looked at the plan and said, yeah, it's kind of big enough, and we will probably not get engaged in the cloud optimization, in the infrastructure architecture optimization, and cloud services teams would actually sort of consult on these issues, but maybe the optimization is not top priority because we're not that big experts in the cloud environments, right? And sure enough, it was wrong. So speaking to the rules and responsibilities, I think it's very important to realize that DevOps teams, in our case, client services team, has to work very nicely with the architecture team and development organizations. And we started thinking about delineation of those duties. And Paul actually filled in this matrix. I'll let him say.
Yeah, obviously this was the first step in everything. You know, when rubber meets the road and you start any change initiative, you have to start trying to figure out who's responsible for what. And obviously, a lot of these things, it was actually a change in responsibility. Some groups were typically responsible for doing activities that now operations was going to take over, or vice versa. So it's, you know, sort of, you're playing in my sandbox type thing. How do we get over that challenge? So Greg and I put this slide in here because when we pulled it up, we looked and we saw it was dated May 9th, 2016. So that was how we saw the world when we started all of this. We said, you know, let's put this together and then socialize this across the organization and try to get buy-in and say these are the new responsibilities, roles and responsibilities as part of this DevOps model. So we put it in here. If these slides are shared, it's something that you can take back with you and actually see the different areas, the 10 different areas that we looked at, and how we gave responsibility to either our cloud engineering groups, our architecture groups, or our development groups.
Mm-hmm. So, if we...
Oh, that was a traditional RACI chart.
RACI
so who was
chart,
responsible, accountable, who was a contributor or a consultant, and who you just needed to inform.
So let me go quickly through our development process. This is a very, very high level overview. We have project kickoff. It's a typical Scrum. Sprint Zero focused on the user stories, on shaping user stories and planning the sprints. Right, typical sprint takes 2 weeks, and knowing that we have so many teams and so many products in development, right? Some teams have multiple development environments where they actually develop features independently from each other. Some teams have test and QA environment, and some teams may have just one environment, like QA environment, and they go straight from development to QA. It all depends on the constraints. What's important to note here, we promote containers, Docker containers, across environments, right? And the first time we do the continuous integration and testing in the either test or development environment. And in many cases, test is very automated. Depending on the language that is in use, we use those cucumbers, protractors, super test tools. If none of those tools work, sometimes people build code for testing in Java or C#. I think it's important to note that we run continuous integration using Jenkins as a container by itself. So we build, when the Jenkins job runs, it builds executables, it builds the container, it can do deployment, it can actually run some sort of test, right? And then what's interesting enough here, we do not really push features to stage or production environment as probably you would expect knowing about continuous deployment. And the reason is very simple. We have to reach the MVP stage, minimal viable product stage. That's the way how it works. In healthcare, you cannot really say, sorry, this feature is not available, your medication will not arrive, or we cannot prescribe it, right? So we have to reach that MVP state before we push anything to stage or production. And also we do manual testing here, simply because doctors will have a complete story, everything, the entire flow implemented. So that's a nice chance for them to look at your application, at the workflow holistically, and that's what happens. Now, we also do the volume testing in the staging environment, and cloud helps us in there, because when you deploy your containers in the cloud, actually you could configure other scaling groups that helps you to scale out your applications and tackle the volume problem. So if you look at this approach, we actually did the deployment on top, Docker containers on top of the Kubernetes clusters. And we chose Kubernetes just because sometimes we have to deploy our products in the data center, sometimes in the cloud, and Kubernetes gives you a chance to actually cross those boundaries and deploy your product almost everywhere. But we do have a little footprint of the container services. And those quality attributes that you see here may help you to assess your needs, but keep in mind, remember your strategy. Who is your customer? Where you're planning to deploy your services? So you would not have to spend time on configuration practices.
All right, so we're getting the 3 minutes and cut off thing, so I'm going to go real quick here and just hit you with the quick points here. Point number one, something to note there. The client services team, DevOps team that we formulated, started to participate in all the kickoff meetings for the projects, went to all the morning stand-ups, got involved in the sprints, really got collaborative with the development teams. That was something that was a big change within our organization. Second piece there, about application development, we built up a competency around infrastructure as code. So everything that we deploy, all the infrastructure that we deploy, we write in scripts. We are heavy into AWS, so we use CloudFormation. So we're writing CloudFormation scripts. We're building up baseline scripts based off NIST security template. We can spin up the baseline infrastructure using AMIs for all the instances and resources. We then layer on top of that a database layer, spin up automatically RDS, typically MySQL. Then we spin up the Kubernetes pieces. So we can actually build these layers of the infrastructure using code. So it's quite simple to deploy. Then on number three, when we get into automated deployment, we actually deploy those containers automatically using tools like Helm directly from Git, Kubectl, which is command line, Kubernetes command line deployment mechanisms, things like that. So we're deploying all of our containers automatically from stage in production, like Greg talked about in terms of security. Only the DevOps team does the moves from staging to production. It's all controlled through change management, and actually we get audited by UPMC for internal audits based on those practices and principles. Last thing around production, it's very important. We actually maintain these systems in a production environment. We probably have over 25 workloads running. A lot of them are R&D workloads, but some of them are production. We have about 7 production workloads running from telemedicine applications to large data mining initiatives and a lot of enterprise data warehouse type activities for deep learning activities and machine learning activities. Event and incident monitoring, Greg talked a little bit about this already, but it's a very important role. We're watching the environment constantly. We're reacting to certain incidents that are occurring. We use CloudTrail, watch for API calls. We use CloudWatch, send alerts out of CloudWatch, send a lot of our logs to Elk, a lot of visualization through Kibana, so we're able to get a lot of reports out of there. We write up knowledge pages in Confluence that the development and operations teams can utilize. And security is a big, big issue that we have to deal with. This is one of the ones that we're working on. We have to follow all of the BAA principles of encryption at rest and in motion. We make sure that dev teams are adhering to those things. We're deploying technologies constantly within this environment, like AWS Shield. We're actually looking for new partners around technology and containers for defending containers using technologies like Twistlock. And we actually have the Dell SecureWorks project going on right now where all of our events will come out of our environment and go to Dell, and Dell will run it against their threat intelligence knowledge that they have and actually tell us if there's any bad guys poking around in different areas that they're not supposed to be poking around in. So again, the DevOps world, we own all of this infrastructure and security pieces.
Yeah, we will skip this one. Speaking to the challenges, guys, I think it's one of the very important ones, the cultural challenge. You ship your data to the cloud, and many people feel uncomfortable with that. So it's very important to address those challenges and maybe start small and move towards more critical elements as you go. Looking at the whole diversity of our tools, platforms, and services, single sign-on is very difficult to achieve. So in some cases, we do have to enter those passwords. And the vulnerability testing, if you look at the Kubernetes deployed on CoreOS, it's kind of challenging as well. We have no time left for the benefits and the roadmap items.
Probably do want to say, why do you do this, though, in terms of the benefits? I mean, we did significantly increase the velocity of our engineering teams. We built up this competency around DevOps, and the client services team became much stronger. We use tools like Park My Cloud and things like that in terms of infrastructure, and our cost savings have been incredible in terms of doing capacity management and getting the benefits out of the infrastructure that we deployed. So
we will probably take more questions at the office hours in the conference room D, right? Paul and I will be available. If you have any questions, anything you want to discuss, maybe a little bit deeper than in this presentation, we will be available for you.
Actually, I think we have time for one question right now. No takers?
Did you use your own host VM images, Linux, etc., or did you use Amazon images and then?
Well, I'll probably take that question. We went through that path of doing Amazon will provided some base footprint, right, and we would install layered products. So we did it in some cases, but then we decided that actually it would be more beneficial for us to actually bake our services into containers and use containers on top of the Kubernetes pods. We actually put our containers, images of the containers, in the container registry, in Elastic Container Registry, because it's out in the cloud. We thought we would use Artifactory at the beginning, but Artifactory had to be installed on premises, and we chose ECS just because it's very convenient and it's integrated in all the scripts deploying containers and moving containers across environments.
Yeah, let's have a round of applause for Paul and Greg.